Hello, hello, good morning. Welcome everyone. It's nice to be back. Hello, Coding Garden fan. How are you doing today? How's your Sunday? It's been a good vacation. I'll probably wait until a little bit more people show up to talk about some of the cool stuff I checked out and discovered. But yeah, it was good. I went and visited family. Went to California, and there's no fires around where they are. So in an ironic turn, we get more smoke from California than they get in California. Yeah, the vacation was awesome. It was good. And flying back in was not did not have just like a super high amount of turbulence, which is something that tends to happen here. So I'm happy about that too. All right. How was your couple weeks? Let's see. Going great. Well, that is good as well. We are gonna take a look at what did I name it? It's the improving skills by building ECS library. Okay. So we got a note in Discord. So SOS let us know that there's a problem, there's a bug in my query. Excuse me. Okay, yeah, so SOS let us know that we have a bug in a query. And it is it will return entities that don't have any components, which would basically be deleted at that point in time, which is not appropriate. So let's go take a look at that and verify it, figure out what it is, and then we'll probably create a little video that we can just insert into that course. So it's in here under entities in query. So where? So we have this entire if entity.map. I think it's this one. Because yeah, I think this will return some. Yeah, so let's think about this. What we'll have here is we're going through all of our own indexes. We know what they are, and we're saying, okay, if the entity map and the self.map that we're looking for, so we're looking for position like 1, 3, 5, something like that. So it does the bitwise operations, and if all those together are in the self.map, then return the thing. Otherwise, don't return the thing. So what we want to do is we want to create a test to validate, like to recreate the problem. It's been like 2 weeks since I've done any Rust. Let's see if I remember how to do anything. Ooh, wait. Copilot, are you just gonna run right for me? Run query with no components? It's kind of what I want to do. Run, no. Well, is that true? Yeah, I kind of want to run it with no components because it was going to be a 0. So let's try this. So we know we need to, let's see, we create our entities default, then we're not going to register any components. So we'll do this entities default. Now this, and I don't think we need to register any components. I think we can just create some entities. Maybe we want to register a component so that we can create, we cannot get the other entities. Let's create one component, and then we'll create two entities, one with a component, one without. That makes sense. So in next case, here, U32. Not going to register the other one. Then we're going to create one entity with one component. So entities dot create is it create entity? Yeah, it is create entity with component 10U32. There we go. So just like that. Then I want to create one without. And I think I can get away with that. Then we want to start creating our query. So let me query. Okay, so we start creating our query. Yeah, so far Copilot is figuring this out pretty nicely. Then, okay, so we're going to query with a component for U32s. Okay. Now, once we've done that, we can now do the entire run. So for result, I think it's result, query.run. Then we're going to extract these out. So our U32s is the first one out of here. We're only requesting one thing, so that's fine. Oh, is it that dot one? It is. Oh, right, because the indexes are .0. Got it. I don't really care about the indices because all I want to do is be able to then see what is actually in here. I want to see that we only got one thing. And if we get two things, we have a problem. So we should be able to assert, yeah, assert equal that U32's length is 1. That should be it. Let's oh, can you not run? Because I have errors. Oh, you don't like this? Oh, wait. Why is this inside of the service stand lib? I don't care about that. Oh, this is problems inside of here. That's, I guess I'll need to remove you. And maybe you. Okay, there we go. No problems found anymore. Come on, Rust Analyzer. There we go. Run the test. Well, this result is a problem. We need to return it okay. Okay, Let's try this again. Okay, so one passed. So it did only find one thing. Did only find one thing. So which, and I suppose we should check to see that that one thing is what we expect it to be. That seems, Now I could also delete the entity. So I could create it with, okay, so I could do create entity with component 15 U32. Now if I run this, we should get 2. This should fail now. Yeah, we got it with 2. So now before I run the query, let's just say that too. Then I want to delete one of them, right? So can I do entities dot delete component by entity ID. We know that this is going to be index 01. So let's just do it by 1. So that second one. Now I have to give it the type here. So the type is going to be U32. And then we could run this same exact query again. And now it should be 1. Entities, you need to be, oh, you are mute. Oh, cannot borrow entities as mutable because it's also borrowed as immutable. Let's see. So entities is mutable here, mutable, mutable, mutable. We give this query, so I think what we need to do is drop the query at this point. So we're gonna do a drop the query, and then we're going to start that query over again. Right here. So basically like 2 sort of like sections for this. So if I run this, yeah, so it's passing. So I'm going to go ahead and note in I'll leave these tests in here still, so that way in case like it does cause a problem or anything else. In fact, maybe before I return, let's actually do that. So I've got all of you. Oh, I don't have the my Git stuff. I have to use this right now. Okay, so we're adding tests to check if our query is finding deleted, I guess finding entities without any components. Okay, so what exactly is going on here? Let's also double check that. So why does it work? When we run our width component here, we're figuring out what our bit mask is, and then we're adding that into our map. So we have one thing in there, and so it's going to be a 1 most likely, because it's the first component. And the other one is a 0. So when I'm looking for, hey, do you have a 1? It then checks the bit mask of the other one and says, no, I don't have that. Chantilly cake, hello. Because as we go through here, we say entities. You know what I've never done? I've never actually tried to do the debug mode with this to investigate like what everything is. Can I do that? Will that work? Okay, it's launching. Okay, process exited. Can I do something like this? And then a breakpoint here. Not right now. Stop. Let's do that. Okay, pause and breakpoint. All right, so I think what we can do is see. Okay, see here's all of our variables. So we can see entities. Here's our query, and our map is 7. We have all these type IDs that we're figuring out here. Okay, this is nice. So inside of entities, we have this map 0, 1. Okay, so like we have them. Here's all of our components. I don't need. How do I get some of these panels away? Remove you. Hide watch. Let's hide the call stack. That's fine. Modules. Let's hide modules. You're doing. Oh. Okay, so what we want to see here is maybe not at query. Maybe we want, okay, so we have this query with component before we run. Let's continue. Oh, all right, that, continue. So what we can see is going to happen is going to run this with Have we run this one yet? I think it's about to run this. Okay, so we're gonna run the run command. So if we come up to here, run. Let's throw a breakpoint on here and remove this one down here. Okay, so here we are, and we can see, okay, we're inside of this closure. I can't see the actual values in here, but I should be able to see them in here. So local, we have index is 0, entity map is this 1. So it's 1, okay? If the entity map and self.map. Okay, so self and map is 1. So if they share 1 in the same position, and that's equal to the map, which is 1 here, then we're going to return some index. Okay, so this is the first one, which should be correct. So we're going for it. Now we come back around and we're going for the second one. Now, if we remember, I put in where it's like 2 times. both entities have the same component, so it's going to be 1 and 1, and we're fine. We're getting 2 items there. Now, the second time, we're in index 0, but map and entity map is 1. So that's still going to get it for the first item of the second end. Okay. But now we have something else. We have entity map is 0 because we've removed the component from the entity. Therefore, entity map is showing that it doesn't have anything inside of it. So a 0 and a 1 is going to be a 0. So therefore, it's not going to be equal to self.map here. Therefore, it's going to return a none. And that's the reason why it's working. I'm actually surprised. This worked out really well. We're able to investigate the variables inside of Rust running, which is actually surprisingly nice. Gensies? I can't tell what that character is. Hello. Oh, awesome. I'm glad that it's been helpful for you. We're actually, a community member found a potential bug in that course for the query section. We were just taking a look at it, but I think we're verifying that it's not actually a bug, that things are working as intended. So, I think that, yep, it's all good and running. But if you have any questions about it, I'd be happy to answer them. So, close you up again. Close you up. All right. So what we were checking, Gensies, how far did you get through? Like less than halfway through. I can't remember. Is that query? Did you get to queries yet? This might be farther than you are. So far so good. Be sure to let me know. Not at queries yet. Like 3. Oh, okay. So you just started the actual project itself. Okay. So I'm gonna remove that, and then we're expecting you to be length 1. We don't have to do this drop anymore, and we don't have to do that stuff. So make it nice and simple. So then run this again. Make sure it's running. It is perfect. And then because we have this entire GitHub auto deploy thing that we set up, one side effect of that is every time I do an update and like redeploy, I have to bump a version. So cargo.toml, we're gonna bump you to 1.01. And inside of here, let's do like a notes. Okay, so for 1.01, and community member found a possible bug in the query. Wrote a test to verify the bug, but couldn't replicate it. Test is remaining inside the query.rs file, and let's actually turn that into a link. So that's from README into src, entities query.rs. How do I do this? Word wrap. Okay, that query is remaining inside this file. You're also a web developer by day who wanted to learn Rust to not burn out. Oh, nice. And you wanted to build an ECS because you thought they're neat. Oh, well, it's like kind of perfect, right? Yeah, it's you know, web development is like, I don't know, it's like the moneymaker, right? It's like what everybody's hiring for and what we can like do some awesome stuff for. So I'm glad you were able to find this, and I'm glad you're having well, I didn't verify. Hopefully you're having fun learning Rust and playing around with Rust. Metallic Soul 92. Thank you so much for the subscription with Rust Prime, Amazon Prime. Thank you. Let's see. So that test remains and that. Okay. So that is verifying that the query is only getting components that have the entities, only getting entities that have the components that are being queried for. Okay. So I think that's what I'm gonna put in there. Okay, so that should be good. Let's go ahead and commit all of this. I don't think I need to create that launch JSON file. So just our cargo, the README, and the query. So adding tests. Okay, so just our description is we verified that the entity map and the query map are correct when querying for, I think I can make this slightly bigger. Let me actually do this over here so you can see better. So, and the query map are correct. When querying for entities, the possible bug was that entities could be queried for that didn't have any components. However, we couldn't reproduce the bug with a test. We then we then did the debugger. So we then used the VS Code debugger to step through the function and verified that the logic is running correctly. You haven't tried Rust. You do C development's hobby. You got burned out recently working on an operating system in x86 assembler and C. You saw ECS and you got intrigued. Yeah, so this is not going to be like quite as crazy as assembler in C. ECS is like I make use of like a lot of high level stuff, like a high level language, like functions. So for example, just in our query that we've been playing around with here, in run, you can see that I basically have a vector, and I'm basically like getting to iterate over that, but I'm using this like filter map. So like super high level functions that are like often considered like close to more functional type programming. Still works with object oriented if you really want to. And so I'm able to get that kind of stuff with Rust and not have to make this kind of function myself, which is really nice. Like that's kind of like one of the reasons I really like Rust. Yeah, it's sort of like the ability to do low level and high level at the same time. It's crazy, I know. But yeah, if you have any questions, I'd be happy to try to answer. I myself have never attempted an operating system, and I sort of feel that that's above my my skill level by a bit. Not sure you'd be able to cope with not having filters, maps, reduces in a language. So it's interesting you say that, because coming, like you said, you're a web developer. So coming from JavaScript, like that's, how long have we had that in a language? It's like ES5 introduced that. So what was that, like 2013, 2014? It's been a long time that we've had high level like functions, like those type of array methods in JavaScript. So a lot of languages don't have that though. You know, and if you're coming from JavaScript, that can be quite a shock. I remember it wasn't too long ago that Java didn't have any, like didn't even have functions. It was just methods on classes, and you couldn't do a lot of function type stuff on it. Okay. So continue to write this. We then use the accept the code and verify that the logic is running correctly. I'm leaving the test in just in case I'm missing something. Okay. Quick fix. Couldn't. So I'm gonna go into here. We'll change you and push you up. And also, put up running a test to verify, but okay, and I'm going to, let's go find that code. Okay, so here's that new test that we just wrote. I'm gonna go ahead and get a permalink. Add it for them. I'm just writing in a note to our community member, letting them know that I did take a look into it and couldn't find the problem. It wasn't added as a, it was a direct message as opposed to an issue, so I couldn't like just close the issue. At least I don't think it was. Let me double check. No, there is no issue in here. Okay, so with that being done, they've been in there as long as you've been developing, so it's kind of baked into how you think at this point. No, yeah, I was a system administrator before ES5 came out, so I wasn't doing very much web programming, but like I did a couple little things. And those were the days where it's like, what, you don't have jQuery? What is wrong with you? Are you know, do you even web dev? And that was before like Angular came out and like started the entire front end framework thing. It was basically just, oh, you jQuery and you just hand write everything and you have thousands of lines of JavaScript code that you wrote yourself, and hopefully it works really well. And underscore was the thing before Lodash even. That was fun. Now those are the dark days of the web. Okay, so what is next on our agenda? I think that was like the only thing to sort of like check into and look here. So what I want to do is go back into our deep dive. Apparently I don't have a currently at. Did we just not? Did I completely forget to note that in there? Where are we in here? This is trait into iterator. Or I guess we finished that stuff. So we're in this queue. So we're probably in this. Oh, come on. There we go. Partial equal. So I think we're in compare partial equal. So if you haven't seen this, what I've been doing just recently, I'm sort of in between what I exactly want to do next, and I don't have like a full plan for it. So I've been just playing around with diving deep into the Rust standard library. And so we're going to just take a look at something here, like for example, compare partial equal, and we're going to just take some notes. So I'm going to leave you over here. I don't need to save you. And where's our deep dive? Exploring Rust standard library. So this is compare partial equal. Let's see if this is even something we can do. Partial equal. So standard compare partial equal. And it looks like there's a couple things in here. Let's double check. This is the trait that we're looking at. The trait. So, oh yeah, trait here. Perfect. So the partial equal trait. Okay, so we take the, well, let's go ahead and try to like implement this ourselves. Or maybe as we go through, we'll implement it ourselves on something and sort of like explore into what that is. So we're gonna do partial equal trait. Now, if I remember correctly, if you want to like check to see if multiple things are equal to each other, that's where partial equal really like shines for us. So let's create our main function. Like, so we can do asserts. Yeah, we can just do asserts here. We can just do assert equal like 1 and 1. This is going to work because 1, which is, I think they're both I32s here, both implement equal and partial equal. So therefore I'm allowed to do that. Let's create a custom type though. Maybe like a struct, and we'll just call this like maybe a custom number. Because why not? And maybe you're a tuple type, that's an I32, let's say. And so if I have let 1 is custom number 1, and then let another 1 is custom number 1. But now if I want to check both of these, I guess that doesn't make sense. 1 and another one. This shouldn't work because it shouldn't be able to assert that they're equal. And I don't know if... I guess I just need to run this. I'm in the wrong directory. This is the partial. Oh! Wait. This is the exploring West Center Library. We're going to do a cargo run example, and this is called partial equal trait. So we get this error. Oh, cannot be formatted using, okay, so we need to write debug for this. So derive debug. Let's try this again. All right, so binary operation equal equal cannot be applied to type custom number. In fact, this probably will be a little bit easier if I just do assert. I can just do 1 equals equals 1, and we should get, we still don't get the error in here. An implementation of standard compare partial equal might be missing for custom number. So that's like why we need this trait. So let's continue going through this. Let's actually use this. Equal set for a type and order to any comparisons. Can you read this text? Should I make it bigger? Now, what's interesting here is that there's two functions like this. There's hub trait partial equal. You know, I've never actually, on the right, it's a bit small. Sure, let's make this. How about that? I've never actually implemented partial equal ourselves. Usually I just derive it, which is perfectly fine. That should work just great. Okay, so x dot equals y can also be written as equals equals, and okay. So we could actually just do like the dot ne or dot eq. So that's interesting. I never actually thought that about doing something like that. We use the easier to read infix notation in the remainder of this documentation. Infix? What's infix? Implant or insert firmly in something. A formative element inserted in a word. I feel like that's not helpful. So I don't really know. I mean, I'm pretty sure it's like we use this equal equal instead. I don't know if that's the actual true definition of it. This trait allows for partial equality for types that do not have a full equivalence relation. For example, in floating point numbers, not a number is not equal to not a number. So floating point types implement partial equal, but not equal. Oscar Ellen, hello. Infix means that the operand is in between the arguments. Okay. So it's inserted in between. Okay, so equal equal AB would be the prefix. Got it. So you're using the equal equal because it's the inserted in between the two operations. Got it. Thank you. That makes a lot more sense. Also, welcome. And good morning. How are you doing? How are you doing? Okay, so floating point types implement partial equal but not equal. So, for example, not a number doesn't. So is that true? Can I not do not a number? It's not equal to not a number. So, do I actually have access? Can I do that? Oh, can I find value, not a number? What are you? I guess I could also do an illegal value, right? To create a not number. Like let's say I do let A equals like a character 1 plus 5. And let's just debug A. Let's turn you into an editor terminal. Okay, so can't add that. How do I create a not a number? Oh, standard F32 NaN. Okay. Oh, I can use. Okay, yeah. So it's a. It looks like it's a. Constant. Well, in that case, that works. So let's do. We'll do a debug of. Let's see, standard I32 NaN. Yeah. Apparently, many other people have done this. I think we can do this off I32s too. I think it's on everything. Let's find out. Rest Analyzer is not yelling at me. That doesn't mean it's not. Oh yeah, you're right. Doesn't exist. Okay. I don't need you. Let's do this as an F32. Okay, so we can see here, this is a false. So just like JavaScript, NaN does not equal NaN for F32s. So that is interesting. So floating point numbers only implement partial equal because of like that entire, like after the floating point can be a little bit not great. Your least favorite JS thing? I know. But there's probably where that's the other thing is like that is according to I think floating point numbers, like the spec for floating point numbers. So it's not actually JavaScript's fault. Like some of those number things that JavaScript gets a lot of flack on, all of the other languages have the same thing. The reason why JavaScript deserves all that flack is they only have one type of number, an F64. You want to be able to have non-floating point numbers also. Then you don't get this kind of stuff. Okay, so implementations must ensure that equal and not equal are consistent with each other. Now, so I have to try to break it. Like, come on. Of course I have to try to break it. So let's take this custom number here and let's impl partial equal for you. Wait. No custom? Hold on. Rest analyzer, are you broken? IEEE 754 has a bunch of other oddities. For instance, there are separate values for +0 and -0. Oh, I remember that. Right, which is why you can sometimes get -0 is not equal to 0. There we go. Implement missing members. Okay, so we have this equal here. So we're just gonna say, hey, if self.0 is equal to other.0, then we'll go ahead and say that we're even. But if I take this not equal, they're supposed to be consistent. But what if I just say that you're not equal and I do the complete opposite of this? Re-implementing partial equal not equal is unnecessary. Okay, but I'm just being silly. So now, what happens if I try to do custom number 1 is equal to custom number 1? So that works so far. We should get a true. Now, what if I do not equal to 2? So this should be true too? Wait, for not equal, wait, this is correct then. Hold on, I should make it like this. So if I do not equal to this, I think I'm going to get a true still. I get a false. I get a false because this is not equal to this is false, right? Because these are showing, hey, I think that's how it works. This is not equal is showing, but if I do this and rerun you, we get a true. So we can totally screw up our logic here. We can just like, we can like just turn logic on its head in Rust. That totally allows it. It's not a best practice, obviously, but it is possible to do. Please don't. Epic Blarg, hello. A long time ago, you broke one of the inequality operators while working on a priority queue, and it caused a truly bizarre behavior. It was not fun problem to track down. I can imagine that. Like, if you do this, and it's buried deep inside of a library, because think about it, there's no error here. On top of that, because I have completely different logic now from what this is now, like what if I did something truly terrible? What if I did something like this? Self.0 is equal to 5. So you're not equal only if it's equal to 5. Oh wait, I want to do the other. If like, yeah, you could do sort of like weird things. We can do other.0 equal to 5, something like that. Now, Rust Analyzer is a little bit upset about this, but we don't care about what Rust Analyzer says. We get, like, everything just runs just fine. I'm not even getting these warnings when I run this. So in your case, the problem was made much worse because you were inserting a sorted set, which hid the problem for a long time. Yeah. So, I mean, obviously don't do this. There's a reason why not equal is a default member and not a required member, is that you want it to be the exact same as this itself. So the problem here is that I can just do weird stuff, like just say, hey, we're always returning true. You're not equal. So, hey, are you not equal to this? Let's make this false. So if I do that and run you, are you not equal to this? False. Oh, that must mean it is equal to that. Okay, well then let's do our stuff. Yeah, terrible, terrible, terrible things. Don't do it. But it's possible. So when implementing partial equal manually, the equal method is required, but not so the not equal method. It is a best practice to not touch it. Instead, just set the equal. Very strange bugs happen if not equal is set incorrectly, and they can make you want to quit programming and burn all your computers. Or just derive partial equal. That's the safest way to do this. The safest way to implement partial equal is to derive it. Only manually set it if absolutely necessary. We should make this the most complicated game ever constructed. The user can input data into a black box implementation of a known algorithm and then watch the output, and the goal of the game is to determine which operator has been inverted. Oh god. Oh man, that sort of, that actually could be really interesting. Imagine a game. Imagine a scenario where I like have a virtual machine or something like that, and you can go in and like change any one little thing about something, right? You can like just change one thing, and you have the other player can't look at the source code, can only run things interactively, like through a I don't know, like the play Rust, like the playground interface, and you have, I don't know, 30 minutes to try to figure out what they did, and how close he got to it is how many points he get. Sounds terrible. I'm gonna write down the idea though. It sounds like this sounds like a horrible idea. We're gonna do, oh, I don't even have games here. Oh, insert. Okay, so challenge projects. We'll do fun. This is terrible idea. One player changes something, like setting not equal on partial equal to be wrong. The other player runs code to figure out what happened in a timed limit. I probably won't do it, but I'm gonna have it written down just in case. Anyone here registered any RS domains? I have not. So generally speaking, I've used Google domains. They're not the cheapest out there. And I've also used name.com. And I found like a good experience on both of those. But I've not checked to see if they have RS or not. All right, let's continue looking into here. So I like this. Implementations must ensure. That's actually not correct. The language doesn't actually check to make sure that they're equal to or not during the compiler. Maybe that's something that should happen, but they don't actually, like, it's not a must, it's a should. Like, you really want them to be the same. Okay. If partial order or order are also implemented for self and right-hand side, their methods must also be consistent with partial equal. Okay, so the partial order stuff also has to be consistent with that. I think... Okay. The equality relation must satisfy the following conditions for all of A, B, C, and D of type A, B, and C. So symmetric, if A partial equal B and B partial equal A, then A equals B implies B equals A. So I don't even know how to do any tricky things to make that not work. Like, I guess, like, I'm not devious enough to think of a way to do that, to break the symmetric system. Derivable. This trait can be used with the derive when derived on structs. Two instances are equal if all fields are equal, and not equal if any fields are not equal. When derived on enums, each variant is equal to itself and not equal to the other variants. So I have done that myself. Now, this does sound like a possible use of this would be if you do want to check to see if two structs are equal and they have different things inside of them. But perhaps there is a valid use case for that. Like if you have an ID field, but like the data is the same. So let's take a look at that. Like an actual real use case for this. So let's say we have this, we don't care, well, here, custom number, we're gonna now derive partial equal for this. So we don't need to have this broken thing here anymore. But I'm also gonna have like a struct. Let's have this be like, I don't know, an entity. We're gonna do ECS style here. So we're gonna have an ID, which is a U32. And then we're gonna have, I don't know, a just sort of like some other number. Let's have like the name be a custom number for some reason. I don't know why. It's a custom number. That, oh, health. We'll do health. Its health is a custom number. Now I don't want to do partial equal on this because the IDs are going to be different each time. So instead, I need to impl partial equal for this. So for entity, okay, you really want me to do that here so you can figure out to go in there. Then we're going to say, okay, so self.id. Now I want to make sure that it's not both things. So I don't care about the self.id and other ID. I only care about this health. Self.health is equal to other.health. That's it. Field is never read. That's fine. And do you have all your REST standard? No, I don't. I don't really have it as a standard playlist. I've been throwing that into the just the raw full streams recently. That's sort of like what I've been doing, especially since I sort of like do other stuff in there too. I don't know. I keep on going back and forth on how I want to organize the playlist, and I'm really terrible at that. So they're just in a raw full streams. All right, so now let's do like player equals a new entity. And so we're gonna have an ID of 1 and a health of a custom number 100. And then we're gonna have an enemy is ID 2, but custom number 100. So I wanna see if they're the same. And they should be. So I wanna see if player is equal to enemy. And if I run this, we should get true. They are the same as that because that partial equal is checking the health and not the ID. Which is, so like, this is a potential valid use case for it. It's maybe a terrible example because I don't think one would ever want to actually do this, but it works. Now I know because like, you know, coming from something like JavaScript, partial equal is really nice because in JavaScript, all objects are, you know, different. You can just have like two objects said like, hey, are you equal to each other? And it's like false, even though they have the exact same stuff in them. So we can say that partial equal is not checking to see if the reference is the same. If like, you know, do I have the same thing in memory? It's really, does the thing that I have the same values inside of them? Yes or no? And it's deeply nested. Like, are the things inside of them partial equal to each other? So you can see that this has to then dive deeply into there for that. So that's actually like really, really cool. KJH, hello. Also could be useful if you're implementing a smart pointer like a box or a vec myself. Right, and I want to like then control that. Definitely. Okay, so continuing on. So an example implementation for the domain which two books are considered the same. If their ISBN matches, even if the format's different. So that's very similar to what we just did. So I don't think we need to like look through this too much. Because like it's really just checking that one thing. Kind of exactly what we're checking for. How can I compare two different types? The type you can compare with is controlled by partial equals type parameter. For example, let's tweak our previous code a bit. So they derive partial equal on this book format. So we can do impl partial equal book format, so pass the type in, and then that means this other is going to have this book format. And then for book, oh, so then we know that the other is going to come in as this book format. So if you want to control what this other is, you have to then set that here. And we've done that several times with other things. I think we even did that inside of the ECS library. By changing import partial, we allow book format to be compared to books. A comparison like the one above, which ignores some fields of the struct, can be dangerous. Right, because we can start like forget that we don't have partial equal for some types, but have it for others. Dangerous. So generally speaking, a derive is still the best. As you can see here, derive. And then we can override if we really want to for the things that we're looking for. Required methods. Okay, so we have EQ. This is our notes section. Okay, so we have EQ. Basically, test for self and other values to be equal, and is used by equal. So this is the required method that will check self and an other for equality, turning a Boolean. This is used by equal, but can also be called by equal directly. Okay, then we have this provided methods. So provided methods in Rust are these trait methods that are like already set up for us, and we don't need to really worry about it. So we have not equal. So it basically just, if we take a look at the source for this, oh, it's a macro. Wait, we know this. Oh, here it is, not equal. Yeah, we can just see it. Look, it's just bang self.equal other. That's literally what it's doing. So it is literally just calling the equal function and checking to see if it's the opposite of it. So the source code calls equal above and returns the opposite of it. Overwriting this can have very strange consequences, but is legal. Please don't. And then we have our implementers on foreign types. So partial equal. Okay, and then the implementers, like all the things that implement it, so we can see all these different types that auto put it in for us. So like that I32, there it is. And everything else. Now it's interesting, look at that. Impl partial equal for bang. Does that mean I can actually... Can I debug bang equals bang? Like, No, that won't work. Yeah. Bing is a bottom type. That's what I thought. It's like essentially a nothing, like absolutely nothing. But apparently it's like, so I can't use it, but I can use it. But I can do this with like this. This should work. Maybe. Yeah, this works. So it's true. They're equal to each other. So tons of things where it's set up, and I think that's it for the rest of partial equal. Yeah, it does feel like kind of useless for that. I'm actually curious. Can we go back? I want to see the source code for this. Yeah, look at this. Oh, it's an unstable feature. Impl equal for bang. There it is. Oh, wait a second. That's equal. Here it is. Impl partial equal for bang. That is really interesting. So there was an issue at some point in time where it had to be set up for that. What is it, bottom type, or is that too, let's see. I don't know if I can properly search. I think we're done here, right? There's nothing else for us to look into. Yeah. Can I even search for bang? Is this never? So it's this primitive never type. It's a nightly only experimental API. It represents the type of computations which never resolved to any value whatsoever. For example, the exit function exits the process without returning, and so therefore returns itself a bang. Break, continue, return also have a return type of bang. So we can technically write let x, which is this bang. So can I do something like this? It's like here we have this main. Can I actually say let x equals return? Yeah, look at that. Return 5. Rust Analyzer knows that this is a bang, and so it shows that for us. So even though I can't really directly use bang, Rust Analyzer will show it when it's happening. So we just did compare partial equal. Let's go ahead. Nope, don't want to save you. I don't have that in here. Okay, let's open up exploring. Oh, did I never commit this? Is this never committed and sent up? Well, we need to fix that. So here's all these examples. Change this. So, I guess it's just the initial commit. Sure, let's add. There we go. If you all would like to go take a look at this as I'm doing it, it is right there. All right. What's next? You are done. So partial order is next. And it is partial ordered trait. Okay, so we have this trait for values that can be compared for a sort order. So this is like similar to partial equal. It's allowing us to tell like, hey, what order should things go into? The less than, equal, greater than or equal methods of this trait can be called using like the less than equal. Okay, so we can call them with like .lt or just less than. The methods of this trait must be consistent with each other, so we can once again screw things up if we really want to. You know, this kind of makes me wonder because like there's you can make probably some really nasty code that like changes some of these things that you wouldn't necessarily think to look on in like an open source project that could probably create some security holes or violations. I don't know. Some really nasty stuff, I bet though. And it might like fly, it might like be able to get through like the test sections of like a lot of things. Maybe. Okay, so the meds. All right, so we basically, it's the same thing as the other one. They need to be able to like, math needs to happen. If orders also implemented for self and RJS, it must also be consistent with partial compare. Right, because you can't tell to see if something is less than something if you don't know if it's the same as something. Okay, so let's take a look here. Now, if we do the exact same thing that we did before, so we had this struct custom number that has an I32 in it, and I tried to debug, I want custom number 5. Man, it's almost like you know what I'm doing. Custom number 5 is less than custom number 10. So we expect this to be true. If I run you, we just get an error. It doesn't know how to do that. So it wants us to where an implementation of partial ord might be missing. So that's what we do here. So impl partial ord for custom number. Implement our missing members. So we get this partial compare here, and we're gonna get an option, and we have to return this weird ordering thing. Unsafe code should not rely on partial equal, partial ord, impls, because you can implement them wrongly. Yeah, exactly. So partial, okay, so partial compare, now it's this weird option. So I guess we'll get into like what that option is. And what do I take in? I take in self, and I have this other, but that's still the self type, but I need this ordering. Now, I couldn't just always return none, because why not? Partial equal is not implemented, so I do need to derive partial equal. Let's derive debug and partial equal. Yes, I know. So if I run you, I'm going to get false right now because it's a none. Let's continue on. Okay. When derived on structs, it will produce a lexicographic ordering based on the top to bottom declaration order of the struct's members. When derived on enums, variants are ordered by their top to bottom discriminant order. So you can sort of like control the order based upon the source code. That's kind of fascinating. Okay, how can I implement it? So that's actually sounds like a note thing. So implementing cells ord will use the declaration order of struct and enum members, which is super fascinating. That's how it chooses what to do. How can I implement partial ord? Partial ord only requires implementation of the partial compare method with the others generated from default implementations. However, it remains possible to implement the others separately for types which do not have a total order. For example, for floating point numbers, nan is less than 0 equals false, and nan greater than or equal to 0 equals false. Which is actually a standard, right? Like that, they literally write out, this is what it's supposed to be, but I could overwrite it. Partial order requires your type to be partial equal. Okay. So we have to have this ordering here. So impl partial order for person, function partial compare. Okay, sum self compare other. So, oh, but this drives equal. So we're still getting ordering. So health dot height. Okay, so this is where we're just saying like, hey, we're doing this height partial compare. And then the other dot height. Okay, so to do this ourselves, we're gonna have to bring in ordering. So I think REST Analyzer will bring this in for us. But we're gonna use this partial compare. So we need to run this on this thing here. So we're gonna do return, and it's gonna return, so partial compare is gonna return an option. So self dot partial compare, and I guess other, which is a reference, and that returns an option ordering. So if I just do that, and this is the reason why I could just derive it. It's pretty simple. Now I could also do self.0 to get into here, dot partial compare, a reference to other dot 0. And this should now give me true. Here we have that. And Oh, interesting. I don't have to use that. It just works. Now I can also use the compare. So compare, and we'll just do other.0. Oh, and this returns an ordering. So then I have to wrap this in a sum if I want to use compare itself. Expected, oh, reference, so it's still a reference. And this also works. And of course, if you want to be silly, then we just do not. And now, no, I can't do that. Oh, it won't let me. But you could do crazy stuff like +5, or I guess in this case, like -50. Like it will let me do weird stuff like that to just sort of break it. And it's like, hey, 5 is less than 10, false? What are you talking about? What's going on? Well, that's because I have -40 in there. But it doesn't know, and there's no way for me to find out unless I like dive deeply into it, which would be crazy. So once again, don't do stuff like this. It's just gonna drive you crazy. Okay, so we want to just do the self. Partial compare. I mean, technically this works like that. If we did the struct like we did before, where we're comparing like something inside of it, that would also work, or we can just derive this. But I think the note is in here to import this ourselves, run the partial compare method on something that we have access to. That will return the, what is it called? Ordering. All right. So let's go into required methods. This method returns an ordering between self and other values if one exists. So what's interesting is I think this is going to run it multiple times, right? So can I actually do something? Can I do something crazy? Let's try this. Let's throw a debugger on here, and we'll run debug. Maybe. Oh, the variable workspace where it can be found. No such folder exploring standard library. What? Okay, fine. I have to tell you. Oh. Huh. So program space folder. So it doesn't know how to do this. This is, oh, because I have to tell it arguments. I have to do something like example. partial or rate. And our program is no, wait, wrong one. Oh, wait. This is the wrong launch JSON. Hold on, stop, don't save. Remove you. Now will you work? Did I break you? Now you work. Okay. So we've breakpointed on this line here, so we can see that we have our self and our other. So our self is this 0, 5, and our other this 10. And I think that's gonna be it. We only have like this one thing going on here. So then I kind of want to then come in here and then just assign this. So like let, you know, x equals, and then let's return x. We'll put a breakpoint here. Wait. Okay, so here at this x, oh, I think I have to start over again. What? You won't let me look at x? Okay, give me a watch. X. X is X. Well, it's not helpful. I can step. Or not. I don't want to go into the hex. Oh, problem there. Syntax error. You're correct. I had a syntax error. That was. Yeah. Right, let's now see. Breakpoint here. Oh my gosh! Stop all of this. Okay, rest on panic. I want there. Go. Huh, why is it not going to the end? So I don't see the X here. It's kind of like not what I was expecting to do for like the breakpoint. I kind of expected it to stop here, but it doesn't. I wonder if it's being compiled away, so it doesn't actually exist. What I can do, maybe, can I just do a debug on X? I guess you have to be a reference X. Let's do that. Okay, so we have, oh, look at this. Okay, so what we have is literally less. It's an enum. So it returns this less. I don't know what I was expecting. I guess I was expecting ordering to be something else. And if it's greater than that, it's going to be something else. Can I debug this and actually take a look now? Yeah, here we go. So X is a none at this point in time. So it's a none. Now we're taking a look at 5 is less than 10. So I would expect that X would actually be an option, so a sum with less in it. But that's not true. And if I step over, then you just become this less. Huh, interesting. Did not expect. Configuration. Let's add a config for you. Sure. And then I think with these, we can just do example. So if I do that, save you, and I want to do, what is this called? Debug unit tests and library. No, you're going to be titled just current example, maybe. Now if I re-put something there. Oh, unrecognized option example. Oh, I was hoping that would work. But I guess I need to like figure out maybe a little bit better to get it working that way I want it to. I'll have to play around with that later. Okay. All right, so now we can go take a look at ordering. And we should verify that we have that in our list. Yeah, compare ordering. So it does live in here, so we'll be fine. So in ordering, yeah, so less, equal, or greater. The arms, like what? Not values, it's members. Okay. Then we have these like LT, LE. So this method tests less than for self and other and is used by, okay, so then uses the partial compare method to check something is less than something else. So I guess if self is less than other. And it's really going to be the same for all of these. So I can just copy this because you're going to be then less than or equal. Is less than or equal to other. And then there's greater than. And then is it GE? Yeah. And then just the implementers on foreign types. Okay. And then we're done. Okay, so we've closed all this. Don't need that launch. All right. What is next? So equal is next. So you're still in traits. All right. The trait for equality comparisons, which are equivalence relations. What does that mean? In mathematics, an equivalence relation is a binary relation that is reflexive, symmetric, and transitive. The relation is equal to is the canonical example of an equivalence relation. So this is equal to that, but I think it's like a true equal and not just a, well, partial equal. This means that in addition, okay, so it's this symmetrical, okay. This property cannot be checked by the compiler, and therefore equal implies partial equal and has no extra methods. This trait can be used with derive. When derived, because equal has no extra methods, it is only informing the compiler that this is an equivalence relation rather than a partial equivalence relation. So I guess, well, equal implies partial equal. But if I do the same thing that I normally do, so let's derive debug, and we have our custom number. So we have a struct custom number with like an I32. And I impl equal for custom number. So assert receiver is total equal. That's, wait, that's the function on it? How can I implement equal? If you cannot use the derive strategy, specify that your type implements equal, which has no methods. Oh, okay, so interesting. So there is no, That's just it. This is how you do it. Equal like that. But it won't let me do this unless partial equal exists. Required by this bound in standard compare equal. So I was sort of like wondering whether or not I could create some sort of like weird, hey, are you equal to each other, but don't check, partial equal. And no, I can't. So Rust forces me. So cannot implement equal without. I guess I might as well just do it like the app. Partial equal. This means, so what does this really mean for us? So in let's just open it up because it's fun. For those of you who are familiar with JavaScript, this is going to be like, something everybody just knows, right? So if I say, like, I like to use var when I'm doing it here so I can redeclare the variables without having to refresh the page. So if I do var like a equals an object, with like a is like, I don't know, number is 5, something like that. And if I do var b equals exactly the same thing, number is 5, and I test to see if these are the same, I can do console.log a is equal to b. And if I do this and I run that, I get false. But instead of this, like, b equals this, if I instead say var b is equal to a, then a equals b is going to be true. And that's because a and b are reference types, so it's just pointing, they're just pointers to a position in memory. So think like stack and heap type things, like it's really on the heap and we're just like pointing towards that place in memory, like a box almost. You can see it as equal says that in addition to partial equal, it's more strict than partial equal. Yeah, exactly. So in JavaScript, we can run into this problem quite often, but we can't in Rust because Rust forces us to implement partial equal. And partial equal does say, well, yeah, you're not equal exactly in memory, but let's go and check the values too. Are you equal? Oh, you're partial equal, so therefore we're good to go. And partial equal does the equal thing, so therefore it works out this way. So I find that that's really fascinating, that Rust won't allow you to get into that situation because it forces you to implement partial equal. Now, I do guess they would probably do the equal first and then do the partial equal, but I don't have any insight into like behind the scenes for that to find out if that's actually true. And there are no methods. It's like there's absolutely no methods in this, so it's just like then, hey, here's what actually does true equal. And we can see there's a bunch of these, like all the what are they? The basic types, including that bang again. So I guess we can do this, but only if we have partial equal in here. There. Equal is not implemented for floating point types, though. That is correct. Equal is not set for floating point types. So like, equal is not set for floating point types, like F32s. I think that's the reason they're split like that. Yeah, I think you're right. And when we get to floats, we'll probably see the partial equal auto set for it maybe does something crazy, like checks only a certain amount of decimal points before it just says, yeah, you're equal. But we'll get there when we get there. Okay, so ORD is next, but before I go off and do that, I need to go refill my water. So I am going to take a super fast break, only a minute or two, and I'll be right back. All right. Oh, you like how some libraries call methods dangerous to discourage you from using them. I believe Rust does it, and you notice Letter does it so as well. I don't know Letter. But yeah, like they'll say things like dangerous. Don't use it, but here it is. Yeah, it's strange. Like why even make it available? Just don't do it. Oh, okay. So you think you found a reason that the debugger was showing the none when it was actually some? What is that? Was it like my debugger setup? Or is it actually just something else? So ordering is defined as pub enum ordering less. Oh, I didn't pay attention to that. Oh, so ordering less is equal to -1, equal to 0, greater is equal to 1. Oh, and the debugger probably couldn't figure that out because it actually was -1, 0, or 1 due to compiling down to like the simplest things. An option is special and the compiler optimizes it to none to be case to be 2 in this case. Oh, strange. So the debugger just couldn't figure that out. Even like, yeah, so it's a case of the debugger and the language, the compiler not speaking the same language, not communicating with each other properly. I don't know if that's the right word. So the actual value is -1, i.e. less than. Yeah. Yeah, that makes a lot of sense. Okay, so we're on ord now. Ord. So trait for this. Ord for you. Notes. Not that. Notes. Okay. I don't know if we need like another notes, like another actual code for this one, because partial ord, I think, is very similar to this. It's just the owned version of partial ord, I believe. Trait for types that form a total order. Implementations must be consistent with partial order implementation. Okay, so can be derived and probably should be derived. Should be derived when possible. Like just always do the derive if you can. Is like my rule of thumb for this. It's easy to accidentally make compare and partial compare disagree by deriving some of the traits and manually implementing others. I mean, that totally makes sense. We humans make mistakes all the time, so why should we even give ourselves the chance? Corollaries. From the above and the requirements of partial ord, it follows that less than defines a strict total order. This means that for all a me, okay, so the standard ordering things exist, derivable, lexical comparisons. So two sequences are compared element by element. The first mismatching defines which sequence is greater than or other. Okay, how can I implement ord? So partial ord and equal must be set. So to implement ord, the thing must also implement. So it's going to be partial ord equal and therefore partially. And then it's going to be the exact same thing as partial ord. We compare by using this CMP instead of the partial compare. So required methods. And we can actually go take a look at this ordering. And we can see, yeah, we're gonna have to go look at the source code for this. And here's where we see ordering less is equal to -0, equal is equal to 0, greater than or equal to 1. There we go. So required methods. Max. Okay, so compares and returns the maximum of two values. So, oh wait, required methods. I'm doing it wrong. Compare. What am I doing? There. Required methods is CMP. It's the same thing that that happens in partial equal, except it's just owned instead of a reference. I guess the only difference that it turns a variable, no, an owned. An owned ordering. The reference to an ordering? I think a reference. Instead of a reference. Oh, ordering. Okay, so yeah, you're right. It returns an ordering instead of a option. Do I have an option in here? I feel like we should have an option. I do. Okay. And that's really the only difference there. But these provided methods are a little bit different because I don't think we had these inside of partial ord. We can see the oh, these are okay. Provided. Forgot that. These methods are just like provided for us. Less than equal, greater than or equal to. But you we have different ones here. So we have like max. So comparison returns the maximum of 2 values. So that's actually kind of nice. So now it's probably using compare behind the scenes, which is why it's a provided method. Like, we don't need to implement this ourselves. And then we have min, which does the exact same thing, but for the other side. Now clamp, restrict a value to a certain interval. So returns max if self is greater than max and min if self is less than min. Otherwise, this returns self. So this is actually pretty interesting. Now, this is a provided value. Right. We don't have to implement this ourselves, but it allows us to sort of like deal with this. This is helpful, I think. So I kind of do like the idea of maybe doing this. Do is this ord? Ord, great. So let's say we have like let I don't know, let age equals I don't know, somebody put in like, you know, 10,000. And for some reason it's an I-32. I don't know why. We just did that. So for some reason our age has been set to 10,000, and I can debug this age. And we'll see the run, and there's our 10,000. Great. Very silly. But I want to clamp this. So I can actually clamp you right here because it's part of ord. So I can say min, well, you can have a minimum age of maybe like 1 and a maximum age of maybe like 100. People do get older than that, so let's just say like 110. I don't know what the actual oldest human ever was. Certainly it's not going to be much over 110 if that's the case. And so then if we debug this age, it should be 110 now is what this is going to be set to. And there we go. So it's nice that like this runs like this. So clamp. So what does this do? This it's like limits a value to between a provided minimum and maximum values. So this one is nice. I can see this one actually being used. And I can also see you needing to do this one yourself if you're doing something different, like on an object or something like that. And using their clamp as opposed to overwriting and creating your own could be really helpful. In game dev, this might be doing something like setting the maximum velocity. Like we want to clamp all the velocities to a certain value, which I've done myself several times. And then that's it on foreign types. Okay. Gosh. Let's okay, this is gonna be different. Let's go take a look at hash. Now this is the trait hash. Right? Is that true? Wait. Yeah, this is the trait hash hash. Here we go. So what do? A hashable types implementing hash are able to be hashed with an instance of hasher. We'll talk about self-reference definitions here. Implementing hash. Okay, well let's go on until we figure out what that really means here. You can derive hash with derive hash in all fields if all fields implement hash. The resulting hash will be the combination of the values from calling hash on each field. Now I've noticed that I have to like implement hash if I want to use something as like a key in a hash map, for example. And of course, we can implement it ourselves. So how does this work? So we implement hash for person here. So it's this hash method that takes in this hasher, h hasher. It's a generic? Yeah, it must be a generic. Because the state is this H. Interesting. Okay, so self, and then we have the state. And then self ID hash the state. Self phone hash state. That seems weird. Oh, we're recursively essentially calling hash on everything inside of here. That's kind of what's happening. So we're calling this hash on everything inside. So let's do this ourselves. You pass around the state and let things hash themselves. Essentially, yeah. Now, if I want to go all the way down and implement hash for everything, eventually I'm going to get to something that auto implements hash, and then I won't need to ever. So that's probably what would happen. So hash create press. So let's say I do want to, let's see, sure, I want to create a hash map new. And I want H to be a hash map of, going to be a hash map of, what's my key going to be? My key is probably going to be this, like our custom number. Let's say we have our custom number again. So we'll do a struct custom number. Sure, we'll do something like that. So now i32s implement hash, so I won't have to go one level down with this. So we'll do our custom number is the key, and then the value is like, I don't know, another number. So like a U32 for some reason. I don't know. Yeah, let's just do a U32. Now, what's going on here? Does not need to be mutable. Now, if I try to import you in, so can I say like a dot or h dot insert? We'll need a custom number. Number is like 5, and our value is like, I don't know, 10. Let's debug this, and then we will debug h. I can use a hash set. Probably, yeah. But the method insert exists for struct. There's trait bounds. There we go. Okay, so custom number must implement equal. Okay, so it must implement equal. We can just do that here, which is going to give it, partial equal and equal. And then it also must implement hash. So we're going to implement hash for custom number. Wait, rest analyzer. What? Oh, derive macro, wrong one. Oh, that's our problem. You are standard hash. That's our problem. Implement the missing members. Okay, so function hash here. We have our h, which is the hasher. So we have the state that's the hasher itself. And we can then return, and we don't need to return anything. Notice this, it doesn't return. We're just gonna say self.number.hash state. And that's because that's what this is here. If we had more members, then we'd have to just run this for every single thing. So I almost don't need to do anything here. And that's why you are implementing hash explicitly, but have derived partial equal. Clippy. Oh, Clippy won't let me do that. But I think I can still run this. And the compiler is okay with me doing this. It's just Clippy is yelling bloody murder at me for it. But yeah, there we go. Now I can have that as a key. Okay, so hash and equal. When implementing both hash and equal, it is important that the following property holds. K1 equals K2, hash K1 equals hash K2. I guess that makes sense, right? In other words, if two keys are equal, their hashes must also be equal. Hash map and hash set both rely on this behavior. Thankfully, you won't need to worry about this because you can just derive hash, and you probably should derive hash. Okay, so for hash, it just like feeds this value into the provided hasher, right? So really what we're doing is just running the hash method on all of the members of self. I mean, that's pretty much what we're doing. Now there's a provided methods for us too. So hash slice. Okay, so hash slice, where that H, the generic H, is a hasher. We're going to get data, which is a so that's going to be a slice, an array slice of, well, self. And then we have our hasher. Feeds a slice of this type into the given hasher. This method is meant as a convenience, but its implementation is also explicitly left unspecified. It isn't guaranteed to be equivalent to repeated calls of hash, and implementations of hash should keep that in mind and call hash themselves if the slice isn't treated as a whole unit in the partial equal implementation. For example, a vec deq implementation might naively call as slices and then hash slice on each slice. We're going to get into those later, I think. But this is wrong, since the two slices can change with a call to make contiguous without affecting a partial equal result. Since these slices aren't treated as singular units and instead part of a larger deq, this method cannot be used. So a vec deq implementation might naively call as slices and then hash slice on each slice. So basically don't do that, because like bad things could happen. So we create a hasher. We have a numbers, and then we can say, okay, off of hash has hash slice, interesting, that's not a hash slice off of hasher, but off of the full trait. Hash slice, numbers, and then hasher. Right, because look at this, it doesn't take in self. So it's off, it's like essentially a static method. So it's the equivalent of a static method. And we get hashes and a hasher, which is just this default hasher. But I suppose we can have other hashers too. And then perhaps, for example, the various hash maps and hash sets have their own hasher, I bet. So let's actually play around with this. Let's see if we can like recreate that. So if I do, so let's do like numbers. We'll do 5 of these things. We'll have a hasher. Here's our default hasher. Okay, and then we'll be able to do a hash slice, or hash slice. Our data is going to be a slice of these numbers. Now, if we remember, we can actually just slice this by getting like, you know, some number of them in there, or I can just do the full amount. So I can just say a reference to numbers if I want everything, or I think I can just do like, what was it? It was like 2, 3, something like that. And then our state is going to be the hasher. And we're going to it's a mutable reference to this hasher. So you need to be mutable. mute like that. And then we're going to debug the hasher. Yes, I know you're upset about that. I don't care. So here's what we got out of this hasher now. So our length is 4. We have our various states, tail, end tail, and our marker. So we've hashed it. I wonder if those are type IDs. No, they can't be. They have, because they would be the same thing. So I wonder what those specifically are. Because I'm also not seeing our data in it. But we haven't got into like a default hasher. Do we have default hasher in here? No, it's just part of collections. Okay. Oh, that is the only thing that we see here. Collections hash map default hasher. But this is off of. Oh, yeah, we are. Map. We're using default hasher off of map. So it's like, it works. It's interesting. So if I do just the full numbers for this. Length is 20. Length is 20. I guess I don't really know how to read the default hasher. That seems interesting. So I'm not sure I can really speak much about like the hasher itself. And I think there is other types of hashers, right? No, there's only one hasher. There's a SIP hasher, a build hasher. But I don't know what to do with those. So we'll just do the default hasher. I still don't know when to use this. Oh, look at that. Okay, hasher dot finish. So you are a default hasher. This is a struct default hasher. I feel like we should make sure that we're covering this. This is under standard collections. Map. Oh, I don't think it's in here. So collections, oh, hash map. Default hasher. Oh, there it is. Okay, so we will be covering this later when we get into that. We should add this to the queue. I don't see it in here. So we'll get to it. So we'll figure out what that finish is later to sort of like understand it. So a static method that will hash a slice using the provided hasher. I guess not really much else to talk about until we explore more about like the actual hasher thing. Okay, so we've got that. And then I think that was it. Yeah, then we're on to implementers. Okay, as ref is next. Used to do a cheap reference to reference conversion. So from a reference to a reference? Yeah, so we take that and return whatever its same type is, but a reference to it. This trait is similar to asMut, which is used for converting between mutable references. If you need to do a costly conversion, it is better to implement from with type reference to t or write a custom function. Asref has the same signature as borrow, but borrow is different in a few aspects. Okay, so normally this just does a cheap version of this. So used to cheaply convert from a reference to a reference. That seems weird, like that wording. And it's not a borrow. Oh, it has the same signature borrow, but it's different in a few aspects. Unlike asref, borrow has a blanket impl for any t and can be used to accept either a reference or a value. Okay, so let's just say similar to borrow, but okay, what's the difference here? So can only be on type a reference. So only be used on a reference. It's more things that can be expressed as references. Borrow also requires that hash equal in order for borrower value are equivalent to those of the owned value. For this reason, if you want to borrow only a single field of a struct, you can implement asref, but not borrow. Okay, so can only use that, but also can be done on anything, really. No restrictions like borrow has. Note this trait must not fail. If the conversion can fail, use a dedicated method which returns an option T or a result. So, warning. Since the traits don't return an option or result, then it must not fail. I mean, really, the only failure will be a crash, which is suboptimal. Generic implementations, asref auto dereferences if the inner type is a reference or a mutable reference. So foo asref will work the same as if foo has type mute foo or... Oh, okay. So like no matter how many limits of this, or I guess 2 limits. If we go 3, it's probably going to be a bigger problem. So if the inner type, okay, so foo asref will work the same if foo has type, okay. By using trait bounds, we can accept arguments of different types as long as they can be converted to the specific type T. Now, normally it's supposed to be the type that we're doing on, but we can do other ones too. So we can do convert. So we have this function is hello that takes in an asref string or stir. S asref so S here, okay, so S, hello, okay, so we turn it into a full string. String can be referenced into a stir, so therefore that works. So I think that's the big thing, is that it's converting. So it is a converting. So converts a reference to a provided type. Okay, so let's create our custom type here. So we have our value. Yeah, in case we want to take in a string reference, but the caller may have a stir or a string, you can use asref stir and it will accept both. Yeah, that's actually really nice. Or in this case, so let's do both of those. We'll do both of those in a little bit. And I think the other thing is that we can do it on a field of something as opposed to here. So we have a custom, let's actually just go into their entity. Entity. So we're going to have a name, which is a string. And then we're going to have a health, which is sure, I32. Now, if I want to impl, so let's say we have some more functions here. So if we have like a function, I don't know why I'm not putting these on the entity, but let's ignore that entire thing. We'll accept anything which can be expressed as a stir, because it's going to try to get a reference to that behind the scenes. So it's going to run those methods. Yeah. All right. So for my main here, No, not main. What are you doing? I want to maybe like print name. Print name. Now, I want this take anything that's expressed as, okay, so I want like the name, like entity name, and you're going to be a stir. And so we're just going to print line, sure, entity name, like that. What I would like to be able to do is say, sure, let entity equals name, sure, Bob, and health 100. There we go. And then I want to print name, and then we're going to say entity dot as ref. Can I do that? Now, right now, no, I can't do this. No method named as ref. So let's implement it for this. So in this case, we are going to do an implement as ref stir for entity. Implement the missing members. And so here we have this as ref taking a reference to self and return a reference to a stir. So this is just going to be a self.name, but a reference to it. And if we do that now, Bob gets printed out. So that does allow me to now just do this as ref. And I don't have to tell it what, because the function is telling it what I want it to be. So that's nice. And then we can also just do a print health. Now this won't work if I try essentially to do exactly the same thing. Use this all the time for two types, as ref stir and as ref. Oh yeah, I can see that. And then the stir seems like it would work really well, and we don't have to implement stirs ourselves on strings because they already kind of do that themselves. But I can see how this could be helpful in your custom types if you just want to like make it so you can just do this. And so if you have two different types of functions, you have like your run functions that's calling other functions to do stuff, and you don't want to have to constantly pass in what types you're doing. This could be helpful. Perhaps this could have helped us in the ECS library. So now we have to implement as ref. Not entity, but as an I32 for entity. And so then this is going to be now just a reference. Now, can I do something like this? Can I say self.health as ref itself? No. Okay, so it's not implemented on I32s directly. So that's going to be it. You have to do that. And now everything works. So, can't be done on anything. We'll probably just say like most useful for being able to take in strings. Or a stir. Is there just a stir in here? Wait, do I not have a stir? It'd be a primitive, right? There, primitive stir. Okay, so let's... I'll go like that. There. And so let's actually set that up for ourselves too. So if I want to create a function, so function, like, I don't know, print string. And we have our string that takes in a stir. We're just gonna print that string. Great. And down here, we're gonna have let name is equal to a string from hello. And then we can just do this print string name as ref. And this should just work. So if I remove these other things, we get our hello. So that's how it can help us out here a little bit. And make it a little bit easier for us to, like, hey, we pass in a string or a stir or whatever we feel like. Now, I wonder if that's going to go away once we get union types inside of Rust. Also, in the other way, like taking s as ref stir. Oh, yeah. We could also just do s as, yeah. We can do that. We can do a generic here. That's true too. Yeah, we can do that. That implements that one thing. I'm not going to do that in this example. Okay, we then have our required methods. Okay, it performs the conversion. So yeah, that's great. So basically, this will convert from a reference to, like, I guess convert, let's just do, this method is run on an object. We'll convert it from itself to whatever type it is required to be. As there's a bunch of, like, implementations for these, which are nice, but clearly not as many as some of those other ones we've looked at. It's like we notice, like, okay, asref stir for string, but like there's no asref for like U8. Well, look at this. There's asref U8 for stir and string. So I can see, are those the ASCII codes? Is that the ASCII codes? So let's say we change our print string here. I actually want this to be I'll just create a new one. The function, I think it's ASCII. We're gonna get a string, which is going to be a reference to an array of U8. And I want to print line the string. I don't know if I need to use a debug on that. So then here's our name. That's instead of this print string, we're just going to do ASCII. So there it is, 104, 101, 108, 108, 111. So that looks to me like the ASCII code for each one of these characters in that string. You think asref and asbytes do the same thing for strings? Let's try it. So if we do ASCII name dot as bytes. They both work. They both take in the same thing. So yeah, that seems to work. Now, of course, I can't like rely on that on other things too. And they're the same numbers, so the bytes are the ASCII code. Okay, and there we go. So that is asref. That's a maybe a slightly more fun one. Now, asmute is next. So I used to do a cheap mutable to mutable reference conversion. This trait is similar to asref, but used for converting between mutable references. So from the name, kind of makes sense. If you need to do a costly conversion, it's better to implement from with type mut or write a custom function. Note this trait must not fail, so same deal. Same auto dereference stuff. Using asmute as trait bound for a generic function, we can accept all mutable references. So exactly the same thing. So add one. So it's basically literally the same thing, except it's a mutable reference. I don't really know if there's much I need to do for like examples for that. So this is like just perform, like does the actual conversion. So converts between an object a mutable reference to an object, and another mutable, or into a mutable reference to an object of a different type. That's pretty much what it is. And besides that, I mean, even like not just besides that, it's just really the same as the other one, but it's mutable instead. Okay, borrow. So this is going to be the trait borrow. A trait for borrowing data. In Rust, it is common to provide different representations of a type for different use cases. For instance, storage location and management for a value can be specifically chosen as appropriate for a particular use via pointer types such as boxt or RCT. Beyond these generic wrappers that can be used with any type, some types provide optional facets, providing potentially costly functionality. An example for such is such a type is string, which has the ability to extend a string to the basic str. This requires keeping additional information unnecessary for a simple immutable string. Right, because it's like, hey, it's really just like figuring out how to like add and mutate and do all this other stuff, but like, hey, just give me a str from that. These types provide access to the underlying data through references to the type of that data. They are said to be borrowed as that type. For instance, a boxt can be borrowed as t, while a string can be borrowed as a str. Types express that they can be borrowed as some type t by implementing borrow t, provided a reference to a t in the trace borrow method. A type is free to borrow as several different types. If it wishes to mutably borrow, then it has to do the borrow mute. Further, when providing implementations for additional traits, it needs to be considered whether or not they should behave identical to those of the underlying type as a consequence of acting as a representation of that underlying type. Generic code typically uses borrow t when it relies on the identical behavior of these additional trait implementations. So I think that's like a key thing here is when using borrow, the borrowed item will have the same traits and behaviors as the original. Like if you borrow something from me, you would expect that it's the actual thing and not just some facsimile that I've converted into that thing, like the as ref. In particular, equal, order, and hash must be equivalent for borrowed and owned. But I don't have to have them. It just, if they exist on the original, they have to exist the same on the borrowed. If generic code merely needs to work for all types that can provide a reference to related type T, it is often better to use as ref as more types can safely implement. So as a data collection, hashmap KV owns both keys and values. If the key's actual data is wrapped up in a managing type of some kind, it should, however, still be possible to search for values in a reference to the key's data. For instance, right, so let's say you do have a key and it's like in a box. I need to be able to like have the equal be in there so I can like equal and hash so I can say, hey, are you the same? If the key is stored as a string, it is likely stored with the hash map as string, while it should be possible to search using a str. Thus, insert needs to operate on a string, while get needs to be able to operate on a str. Slightly simplified, the relevant parts of hash map, key and value look like this. Okay, so we have our hash map. So it's a borrow. Then we just say like, hey, it implements a borrow as opposed to an asref, so that we make sure that it implements a hash and equal and all that other stuff. That stuff. Well, I guess that stuff, really. The entire hash map is generic over a new type K. Because these keys are stored with the hash map, this type has to own the key's data. When inserting a key value pair, the map is given such a key and needs to find the correct hash bucket and check if the key is already present based on that key. Key. It therefore requires K. Don't use borrow frivolously. People will yell at you. Don't ask you how you know. I'm sure you've never been yelled at for using borrow frivolously. When searching for a value in a map, however, having to provide a reference to a K as the key to search would require it to always create such an owned value. Instead, the get method is generic over the type of the underlying key data called Q. Man, so like going all the way into like implementing partial equal for this too. Okay, look at this. Can case insensitive string implement borrow str? It certainly can provide a reference to a string slice via its contained own string, but because its hash implementation differs, it behaves differently from str and therefore must not, in fact, implement borrow str. It should use an asref instead. So here's our required methods, this borrow. So like this is a lot to go into, but basically if we want to borrow something, but we don't want to have the object, the borrowed object, like implement exactly the same as like the borrowed object to implement the methods of the results. I guess that's the result of the original object, exactly how they are, then we should not borrow unless we want to be yelled at. Instead, we should use an asref. So this sounds like if we want to do this ourselves, we can implement sort of like a fake hash map here for this, where we have that insert and get as it were. So if we have something like a struct hash map, I don't really care what goes in here right now, but we want to impl hash map, and we want to have a hub function insert, I don't know what goes in here yet. And we also want to have a pub function get, let's say. So that's what we're doing here. Okay, so we're going to be storing something inside of HashMap. Now we're not like implementing this for reals right now, but we want like insert and get to be able to like handle this properly. So insert is going to have to take in a type T of like the actual data, right? So we know we're going to take in like a mutable reference to self. And get is just going to be a reference to self. Then we're going to have the data that we're inserting. So the data, is that right? Or is it the key data? I already forgot. Oh yeah, it's the key and the data. So we have the key, which is something, and then we have data, which is also something. So we'll just say that this is that K, and the data is D. Now this is fine, but we do have to limit this a little bit. Yes, I have a function main here. Don't worry. Okay, so we have to now set up that we have this K, D. Okay, that makes it technically happy, but if we're going to do a get, we have to get based upon a key, but that's going to be a reference to a K. So looking at this K has to implement hash and equal. So that's the big thing here. Hash and equal. So where K is hash. Do I do a where here? I think I can just also do this here. So, hash plus. Okay. Data can be just whatever it wants to be. We don't really care. Okay. So we have that. Now we're just sort of like ignoring this for right now. If I want to actually I'm probably gonna re-implement these when we get to the struct sections, but I don't really want to worry too much about re-implement during the trait sections. Now for here, we're gonna take in this K, but it's gonna be this reference to a K. We have to make sure that implements a borrow, right? A borrow, oh, the thing that we're returning. That's the key. So get returns a reference to data. So therefore we're going to have this data here. So so K must implement a borrow of D. And now it's just upset that we're not actually doing the thing. So, sure, unimplemented. If I didn't do borrow D, I would have trouble with this now. Or no, if I implemented like the hash differently for what I'm passing in here, that would cause problems because it would be like, okay, I inserted it, but I can't get it out because the hash is different, and therefore it's like not actually partial equal to each other anymore. Now none of this implements borrow on it. Now we know that hash map requires borrow to be done correctly. So maybe we could just use a hash map itself and implement our own sort of like micro string for this. Let's not worry about this right now. Let's do let our entities, it's going to be equal to a new hash map. I want you to be a type hash map with, all right, so what are we going to do for our keys? And the keys is what's really important here. So let's do this as like a wrapped name, a wrapped string for some reason. Like and then we're going to have the actual, I don't know, just like a U32 for maximum silliness here, which means we have to have a wrapped string. So we have a value, which is this string here. Now, as soon as I had done this, we now run into this entire like borrow as wrap hash and all that fun stuff. So if I implement, if I derive debug, we need to do partial equal, and hash all here. That's going to be fine. It's going to be great and happy with us. So let's do let entities. Okay, we're going to insert. Sure. Foo gets 42. Now I want to get this out. So do I have to do borrow on that? Right now I think if I just do it with a reference, I think it works, right? Like let I just call this foo equal to entities dot get. If I try to do something like just a reference to oh, because I don't even have a wrapped string. That's my other problem. I don't have this. So if I try to do like a reference to like value foo to string, something like that. Oh, that works. Well, it's an option. Let's see what I actually got. Found it. Okay, but if we implement borrow ourselves, now I think we have to implement borrow, and then we want this as a conversion. So I want to implement this to essentially a wrapped string for this. Because I can't implement this for something else. Is that true? No, to compare it to like a string, like the string thing, the string stir thing, they're two completely different types. So almost as if I'm gonna have like a struct custom string as well for, you know, unknown reasons. And you also have a value. And sure, you do that. Now, I want to impl borrow for wrapped string or custom string. So here we're going to be returning that reference to the wrap strings. That way it can just call the borrow on it. I think then I can search using wrap string. So in this case, I want a, I have to create it and return the inner thing. I don't know if that's going to work. Because like stir is returning the internal stir. Almost as if I'm returning this value, this string in there. I think I have to then implement partial equal and equal then myself too to handle this. It's like, it's really not wrap string. Oh, I know what I want to be able to do. I know, not this wrap string. Not custom string. If I do this, then I want to be able to search not like this get wrap string. I want to search the same way that a string does. I want to do who like that. I want to search for that. Found reference static string. Okay, so expected reference. Now this wrap string, can I then implement a borrow on this to get that out? And so you're going to return a reference to self dot value dot as stir. Yes, I can. So we do the borrow here, and that gets me the ability to now do this stir here, because it's the hash map behind the scenes is saying, hey, as long as get the thing that we're passing in implements borrow of the thing that we're doing up there and all that fun stuff. Like, as long as that's working. Now let's make sure this runs. It does. So we can do that. Like, this is something we can do. So okay, so hash maps require that the get method passes in something something that can be used to compare against the key. this case, our wrap string can be borrowed using the type of stir. So to allow a stir to allow any stir data to search for it, because stir implements because the value implements that sort of hash and everything else the same as stir does. It's fine. We're good. Now, this will still get you yelled at. Don't do this. But it's like an example of how it works and like how we can actually make something that wouldn't allow us to do this. Now we can. So instead of having to like create a new wrap string like this, just to search for it, we can borrow it if necessary. Which I think is pretty nice. I think it's nice that like this untangles some code and like makes it a little bit easier. So let's see. This immutably borrows from an owned value. Okay, so borrow an immutable like object reference from an object for the required, okay, the type that is borrowed doesn't need to be the same type that the object is. Same type of the object. It can be any object, really, but it has to still follow that entire, like all the other rules of everything else. All right. So we can see a very small number of things actually implement borrow here. So like we can do it for box. We can do it for arc and RC, which is what we saw. We were doing that for RC. All right. Cool. I actually like going through borrow here with this. There's still some like, I still don't know when I would actually use it myself. Like maybe for weird stuff like this, if I'm doing really crazy things with hash map and I really want to be able to do something like that. Possibly would have helped out with the ECS system. I'll have to sort of like keep my eyes open for this one. This sort of feels like it's closer to like something that's really like nice to use, but at the same time, I don't know. All right. Something else I was thinking of in this deep dive, I can do this. Can I not do this? Oh, apparently I can't do that. I have to do that from my other account. Hold on, let me do that really quickly. So switch over here. Find my deep dive. Okay, so copy you. And then over here in any page, here's just sort of like a website which I've currently created, so I can see like where I am and go into it. And then just sort of look through that. So I kind of like this a lot. It's Notion giving me the ability to sort of like just publish a like website of any of the stuff and like nothing else that I don't want to be seen. So that's pretty cool. If you want to go and take a look and follow the notes along with me, I'm gonna go. Let's see, and I think that's that for that. I can now switch back to this one. Operations, dive. And we can remove borrow. Borrow moot is no doubt going to be exactly the same as borrow. I'm going to want to continue with that one next time. Because it's 12:30 and my throat's starting to bother me a little bit. I think I'm doing more talking now than I've done in the past in a long time. So I think I need to take a break from talking for a little bit. I am planning on continuing my my normal like stream schedule, but maybe I have to like change it just a little bit because I do have some meetings that are at odd times for work for my day job, and that's gonna like cut into the streams at like some days. And I don't think I want to necessarily just have to constantly say, okay, well, tomorrow I'm not streaming and, you know, the next day I am. So I think what I'm going to do is set up my schedule to be Monday, Wednesday, Thursday for streaming because I have Tuesday, Friday meetings. So I'm going to go after the stream and I'm going to set up the schedule on the Twitch page so you can see that. And I think I have that down below too. But that's what it's gonna be. We're gonna do Monday, Wednesday, Thursday morning streams, and then this Sunday stream as well. Yeah, I'm really happy to be able to help out with that, Epic Blarg. Also, it's helpful to me too. So I think it's hopefully good for all of us. Oh, and my other piece of news. So while I was visiting my parents, they live in the mountains in like sort of like, you know, that entire like Santa Cruz, California area. And they have terrible internet. I think I mentioned this before. So some people have been asking like, well, what happened to the deck of cards simulator? Well, I didn't want to like sort of share with them until I was able to go there. So I set it up. I tried running it. And I've got to say, satellite internet sucks. Like, it's really bad. Like horrifically bad. So I had my wife in there and she like loaded up on one screen and I loaded it up on another, and we tried to like just like get in the same room and like just open up cards and like display each other. It constantly disconnected from the server, and it also like I would click to like display a card and it would not always catch. Like it would eventually do it after several seconds. It was really bad, even with just a WebSocket. It was terrible. So they have satellite internet, and the speeds are supposedly okay, but that's just on paper only. It's really terrible. So I talked with them, I did some research, I found some alternatives that they can maybe do for high-speed internet. And we'll see. Some of the options I found are actually cheaper than what they're paying for now, but some of them are more expensive. They're on the list for SpaceX's whatever those are called, the satellite internet stuff that they have, which would work out for them and probably would actually solve this, but they can't watch YouTube videos at all. They just don't even bother trying. It's pretty like Starlink. That's it. Yeah, they're on the list for Starlink, but they haven't been contacted yet, which is unfortunate. I think they're a little bit too far south for it. So anyways, I will keep you all updated when I eventually am able to like build things that they can use multiplayer wise. It'll be a good time. Right now, they can only use it if they leave on vacation to somewhere else, literally anywhere else. Which, yeah, it'll be a thing. It also means that if I go and visit them, I can't stream or do anything video-wise. Like I'm just off the grid essentially because internet is so terrible. So, anyways, that's an update on that entire thing. So, with that, everyone, thank you so much for hanging out with me today. I'm going to go ahead and take off for the rest of today's Sunday. I hope that you all have a great day too. And I'll be back tomorrow morning at 8 a.m. Mountain Time to continue this deep dive. Thank you, everybody, and to see ya. Bye.